When you raise your hand and clap your palms together, you feel it, an instant pressure. It feels solid, right? You think your hands touched, that your right hand made direct contact with your left. But here's the truth. You've never truly touched anything in your entire life. Not once. What you're feeling is just an illusion, a convincing lie your brain is telling you. It's one of the most deceptive tricks your brain can pull. And here's the kicker. It's not just the simpletons who fall for it. The smarter you are, the better you are at fooling yourself. Intelligence doesn't protect you from deception. In fact, it makes it worse. The more intelligent you are, the better you get at creating intricate, rational-sounding reasons for things that are completely false. You're a master of logic, but the foundation of that logic, it's broken. Now, before we tear apart everything you think you know about touch, reality, and the universe, make sure you hit that subscribe button. This isn't just about physics. This is about understanding the world you're living in and realizing the illusions you've accepted as truth. Let's go back to your hands. If you haven't touched anything, then what exactly are you feeling when you press them together? It's simple. You're feeling a repulsive force. But why does this happen? Is it magic? Not quite. Imagine every atom in your body like a tiny, dense core surrounded by an immense cloud of negative electrical charge. When you bring your hands together, those negative charges repel each other strongly. It's not like a hard object colliding with another. It's like trying to push the north poles of two extremely powerful magnets together. They don't just touch, they push each other away from the very start. This, my friend, is why you feel solid. What you think of as the hardness of your chair, your handshake, or your phone screen is simply the electromagnetic force in action. Your atoms are not physically touching anything. They're just getting very close, and the forces between them push back. It's an invisible force, but it's incredibly powerful. The chair you're sitting in, the phone you're holding, they're not really solid. They're just full of repelling forces that create the illusion of solidity. But that's where it gets interesting. This is where the illusion comes into play. We've built an entire architecture of common sense, all based on this idea of solidity. But when we dig deeper, we realize that the solid world we experience is far from solid at all. Let's look at the history of how we came to this understanding. Imagine Galileo. He didn't just sit in a chair thinking about how things fall. He rolled balls down wooden ramps. He measured things. He stripped away human assumptions and observed nature directly. He noticed that when a ball rolls down a ramp, the distance it travels depends on how long it's been rolling. This wasn't just a coincidence. It was a fundamental pattern. But even Galileo couldn't explain why the ball rolled the way it did. He just knew the math worked. Then came Isaac Newton, and everything changed. Newton looked up at the moon and realized that the same force pulling an apple to the ground was also responsible for keeping the moon in orbit. And it worked mathematically. That was an extraordinary breakthrough. The idea that the entire universe obeyed the same rules, that the forces on Earth were the same as those in the heavens. But there was still something missing. The big question: how does the Earth pull on the moon? There's no string, no physical connection, just empty space in between. Yet the Earth and the moon pull on each other instantly. How is that possible? This question haunted Newton. He knew the math worked, but he couldn't explain the mechanism behind it. He referred to it as a profound absurdity. But the numbers matched, and we moved forward, accepting the fact that gravity just worked. And here, my friends, we encounter the first crack in our common sense. Let's push the boundaries even further. Imagine Michael Faraday. Faraday wasn't a mathematician. He was a man who loved to experiment with magnets and coils of copper wire. He discovered something shocking. Magnets could push and pull on other objects, not by a string or a physical contact, but through fields. He realized that space itself wasn't empty. It was filled with these invisible fields, constantly in motion. This was a radical shift in understanding. Fields, not magic or invisible threads, were responsible for everything. And the forces we feel, whether from magnets, electricity, or gravity, are just the manifestations of these fields interacting with each other. So now, Let's break this down further. What does this mean for us, for you right now? You think you're feeling a solid surface, like a chair under you, but you're actually feeling the electromagnetic force, the repulsion between the atoms in your body and the atoms of the chair. The chair's atoms are pushing back against yours, and that's what makes it feel solid. But here's the key point. You are not solid. You are mostly empty space. Every sensation of touch, of pressure, of weight, is simply an interaction between electric fields at the quantum level. And when you truly realize that you've never really touched anything in your life, the world around you starts to shift. It's not just the chair or the door handle you're holding. Nothing you experience is as solid as it seems. Everything is just fields vibrating and interacting with each other. You are a collection of quantum fields, constantly pushing and pulling. And in a strange way, that's what connects you to everything else in the universe. Now that we've begun to understand the true nature of touch and solidity, let's dig even deeper into the absurdity of the universe. Think about the chair beneath you once again. It feels solid, right? Your brain assumes that the chair is solid and your body is solid too. But that assumption? It's a convenient trick. The chair, like you, is made of atoms, and those atoms are mostly empty space. In fact, if you took out all the empty space inside your body, you'd be tiny, smaller than a grain of sand. Your body would still have the same weight, but all the physical stuff that makes you you would collapse into a speck of dust. The idea that you are solid is an illusion. And the most surprising part is that this illusion is built from the very same fields that make up the universe. So what does this mean about the world we think we know? Well, let's go back and examine something that's fundamental: the electromagnetic fields that govern everything around us. These fields are the very things making you feel solid. The interaction of these fields, the way they push back against one another, is what we perceive as the feeling of touching. When you press your hand against the chair, what's really happening is that the electron clouds in your hand are interacting with the electron clouds in the chair. And because these electron clouds carry a negative charge, they push each other away. This repulsion is so strong that it prevents you from passing through the chair. But that's not all. The way your body reacts to this repulsion, the way your brain interprets it, makes you feel like your body is solid. But this is just a pattern. It's a behavior of the universe that you're interpreting as solidity. It's not solid in the traditional sense, but instead, it's a complex dance of fields, energy, and repulsive forces. The universe is constructed from fields, electromagnetic, gravitational, and more, that define how everything behaves. But these fields are invisible to us. We can't see them, feel them directly, or interact with them in a way that we're truly aware of. They exist on a scale far smaller than anything we can directly perceive. What's even more mind-boggling is that these fields exist everywhere. They fill the space between everything, from the smallest atom to the largest galaxy. And that, my friends, is the universe in its true form. Everything in constant interaction, a symphony of energy and a tangled mess of invisible forces. And here's the kicker. It's not just our hands that are subject to these forces. Everything is. Every object, every atom is constantly being acted upon by these fields. And those fields are responsible for the structure and behavior of the universe. The reality we see, the solidity of the world, is a manifestation of the interactions between these fields. And yet, we interpret it through our senses as physical, solid objects. That is a massive misunderstanding, but it's one that we cannot help but make. Our minds have evolved to function based on human-scale interactions, on things we can see, touch, and feel. But that's not the full story. Now let's zoom out and look at the universe itself. All of reality, everything we know, is just a big collection of these tiny fields. You, your hands, the air around you, the chair you're sitting on, the stars in the sky, it's all just fields. When you move, those fields respond. When you speak, the air is filled with waves of sound traveling through the atmosphere. When you look at something, light waves, which are themselves fields, travel to your eyes and interact with your brain, creating the illusion of vision. But there's something deeper going on. What you see is not the object itself. It's the pattern that the object creates in the fields. This is the key to understanding the universe. Everything is a pattern of interactions, a result of fields dancing in a specific way. Atoms, particles, light, everything is a collection of fields interacting with each other. And that's what we interpret as the real world. But it's not the real world, it's just an approximation of it, a model that our brains construct to help us make sense of the world. And then there's the deeper mystery. What are these fields really? We can measure them. We can calculate their strength, their movement, and how they interact. But we don't truly understand them. We don't understand why they exist the way they do. And yet, we've built our entire understanding of the universe on the assumption that these fields work the way we observe them to. But there's a huge gap between the mathematical descriptions of these fields and our direct experience of them. This is where we encounter the true nature of reality. It's not about what you see or feel. It's about the way fields work behind the scenes, the way they shape everything in the universe. And that's why it's so difficult to understand the true nature of reality. Our brains are wired to perceive only a small fraction of it, the bits we can interact with directly. But the universe operates on a much grander, more abstract scale than we could ever hope to fully grasp. Now, let's take another step forward and dive into the more unsettling aspects of how we think about the world. You see, the way we experience reality is profoundly shaped by the limits of our own perception. We think we understand the world because our senses tell us that we do. Our minds build a model based on our experiences: touch, sight, sound, but all these are limited by our sensory inputs. The universe, on the other hand, operates on a much deeper level, far beyond our everyday experiences. Let's consider the concept of space. Space is something we often take for granted. We think of it as the empty void between objects, the area in which things exist and move. But if we go beyond this simple interpretation, we find that space is not empty at all. It's filled with fields, forces, and patterns that govern the interactions between matter. These fields are constantly at play, and yet we don't see them. We see objects, we feel surfaces, but what's really happening is a complex dance of forces behind the scenes. Take the concept of time, for example. We think we understand time because we experience it every day. We live in a world that moves from the past to the present to the future, with every moment following the next in a linear fashion. But the reality is far more complex. Time is not simply a ticking clock that moves forward with a steady beat. Instead, time is intimately connected to the very fabric of the universe. Time is tied to motion, to the way objects move through space and interact with one another. This realization forces us to confront the idea that time is not absolute. It's not the same for everyone. Imagine two people, one standing still and the other moving at a high speed. According to the laws of relativity, time for the person moving at high speed passes differently than time for the person who is stationary. The faster you move, the more time stretches out, the more it warps. What you experience as the present moment, the now, is not universal. It's subjective and dependent on your motion through space. This is where our human intuitions begin to fail us. We've evolved to experience the world on a human scale, at human speeds, with human-sized objects. Our understanding of time and space is built from this perspective. But when we stretch beyond that, when we look at things happening at incredibly small or large scales, our intuitions break down. The universe becomes a place where time and space are not rigid and predictable, but fluid, flexible, and deeply interconnected. Think about light for a moment. Light travels through space at a specific speed, roughly 300,000 kilometers per second. This speed is not just the speed of light, it's the speed limit of causality. It's the maximum speed at which information can travel across the universe. But why is there this speed limit? Why can't things move faster? The answer lies in the way space itself behaves. Space is not a rigid backdrop for objects to move through. It's a dynamic, flexible entity. When light travels through space, it's moving through a medium that has a give to it, a medium filled with electromagnetic fields that transmit the information. So, when light reaches your eyes, It's not just traveling in a straight line. It's moving through space, interacting with all the fields along the way, bending and shifting in ways that are invisible to us. This is where our human understanding of reality starts to falter. We think of light as traveling in a straight line, but what we're really seeing is the final result of a much more complicated process, a process of energy transferring, interacting with fields, and bending in response to the fabric of the universe. But light isn't the only thing that's strange in the universe. The very idea of solid objects, like the chair you're sitting on or the hand you're holding up, is also an illusion. When you press your hand on something, you feel resistance. You feel the solid surface, but in reality what's happening is that the electrons in your hand are repelling the electrons in the object. The object isn't solid in the way you think it is. It's made up of atoms, and those atoms are mostly empty space. The solidness you experience is just a result of the electromagnetic forces at play. The atoms are not touching each other, they're repelling one another, and that's what gives the illusion of solidity. This means that everything you perceive as solid, as fixed, as permanent, is actually a dynamic interaction between fields and forces. There's no real hardness to objects. It's all a temporary effect, a momentary relationship between forces that appear to hold things together. Your sense of touch, your sense of being solid, is built on these interactions. But they don't define reality. They're just our brain's best attempt to make sense of what's happening. Now take a step back and think about this. You, me, everything are just temporary arrangements of fields and forces. We are patterns, and these patterns are constantly shifting and interacting with the rest of the universe. The objects we see and touch are not permanent fixtures of the world. They are dynamic, ever-changing interactions between forces and fields. This realization may feel unsettling at first, but it's also deeply liberating. It means that we are part of something much bigger than ourselves, something that stretches across time and space, something that is in constant motion. The universe isn't what we think it is. It's far stranger, far more interconnected, and far more complex than our senses can ever truly grasp. And the more we try to understand it, the more we realize that our intuitions are often wrong. But that's okay. Because understanding the truth, the deeper truth of reality, is a journey that doesn't end with simple answers. It's a journey that constantly challenges our assumptions and forces us to look beyond what seems obvious. And that's what makes the universe so incredibly fascinating. So, when you realize that the chair you're sitting on is not as solid as you thought, or that your hand isn't really touching anything, you begin to see reality in a whole new light. The world you live in isn't the one you assumed. Everything you experience is just your brain's interpretation of a complex dance of forces and fields. These fields are everywhere, constantly interacting, and the only reason you think the world is solid and predictable is because your brain simplifies it for you. But beneath this simplicity, the universe is far stranger and more intricate than we can even begin to comprehend. And here's the truly incredible part. This isn't just theory. This is happening right now. It's happening in the way you feel pressure, in the way light travels to your eyes, in the way gravity keeps your feet on the ground. All of these things are the result of forces we can't see, forces that have been acting on the universe since its very beginning, forces that you, as a human being, are intricately connected to, even if you don't understand them fully. When you start to grasp that you're not solid, when you understand that everything around you is just a pattern of fields and interactions, you can't help but feel a sense of wonder. The idea that everything in your life is part of this grand cosmic network, a network of energy and fields interacting in ways we are only beginning to understand. It's breathtaking. The beauty of the universe is that it is constantly changing, constantly shifting, constantly surprising us. And every time we think we've figured it out, we learn that there's so much more beneath the surface. This is the joy of science, the never-ending discovery that there's always more to uncover, more to explore, and more to understand. We may never fully understand the mystery of why things are the way they are, but the pursuit of that understanding is what makes life and the universe so infinitely fascinating. So the next time you feel solid, the next time you think you've figured something out, take a moment to pause. Remember, that reality isn't what you think it is. It's far stranger, far more beautiful, and far more connected than you could ever imagine. And maybe, just maybe, that's the most exciting discovery of all.